Hey guys, so today I'm gonna go back to the basics, transistors. So I'm gonna use, I'm sure you know about this, Radioshack, experiment, lab, finges. There's a bunch of them. Here I have the 201 electronic project kit, so that's the manual. And those are very cool if you can find them. Usually you can find them like in the thrift shops for pretty cheap. And yeah, they are fun. So here this one and 200 in one, it doesn't the higher the number doesn't mean that it's better. Sometimes it's just different. Like here you have those two ICs here. If I remember correctly, one is like a quad NAND NAND logic gates package. This one, you can see the NAND gates here. And this one I think is also a quad like a flip-flop thing, I think. So as you can see here, there's no op amps, but I have also a 130 in one, and that one has the op amp. So it's different stuff. Anyway, yeah. So today I wanted to talk about something relatively basic. It's a light dimmer. I don't know why it's called a light dimmer, but it has a power source here, a NPN transistor here, an LED here, and the important part is the capacitor. And then you have one resistor here, one resistor there. I think I'm gonna redraw that thing. I think it's gonna be easier. All right, so I did the redrawing. And let me try to explain what the experiment is. So here you have a switch that can go from A to B. So let's assume for now that the switch is on A. So now the current goes like this and like this into the transistor. So what's going to happen? I'm just going to tell you what's going to happen first. So when the switch is on A, the capacitor is going to charge. And what's going to happen is that it's going to turn on the transistor, and then you're going to have current going through here, and the LED is going to light up. There's a slight delay. There's a bit of a delay. So at this point, the LED is lit up. So it's shining. And then what they want you to do is that turn the switch to the B position. Turn the switch to the B position. So this part of the circuit is not here anymore, but the capacitor is going to discharge. And at some point, the transistor is going to turn off. And the light, the LED is going to, it's going to start dimming. So it's going to go from full brightness to nothing. It takes a while. But anyways, the experiment is not that important. What's important, I mean, the result of the experiment is not that important. The important thing is to understand what's going on. So here the transistor is used as a switch. So when you use a transistor as a switch, so that's your base. And I think I've made video about this before. But there you have the collector, you have the emitter, and you have your base here. And here you're going to have some kind of a voltage source. So let's say VCC. You could have a resistance, whatever, but here in our case we have a resistor here which limits the current that goes into the LED. And then you have the ground here, because that's the ground. So that's my LED, and that's my resistor to limit the current. But the idea of using the transistor as a switch is that here, for this current to go through, the VBE must be equal to 0.7. If VBE goes under, let's say, 0.6, then it blocks the gate. I mean, it blocks the flow of the current here. So it means that the transistor is off. So if VBE equals 0.7, the transistor is on. If VBE is less than 0.6 volt, Q is off. That's the idea of using the transistor as a switch. But in general, the idea behind a transistor is that you control this current, which we're going to call IC. You control a relatively large current by playing with the voltage here, the VBE, so the voltage on that side. Okay, so that's the primary role of a transistor. It's a source of current that's controlled by a voltage between the base and the emitter. So again, this is the base emitter collector. Okay, so let's see what happens when you start. Okay, let me get rid of this because I have something else to show. I guess I could have used another one, but that's okay. Let's say that we don't have that transistor thing. Let's say we only have the battery. We only have the capacitor here, and then we have that, fine, the 100K if you want. Whatever. So I remove that whole transistor thingy here. So what happens here? If you just do that, the capacitor is going to charge. You're going to end up with 9 volt here. There's going to be no current here. So the I is equal to 0. There's no current going through. It's completely blocked. And the voltage here is going to be 9 volt. That's how a capacitor gets charged. It's charged, I equals 0, that's it. Nothing happens. But here it's a bit different. Because of the transistor. So what happens? So okay, so the switch is on A, so it's gonna charge. The capacitor is gonna charge. Initially it's 0 here, and it's gonna charge. And I actually wrote the voltage. But yeah. Okay, let's do this. The transistor charges. So what's gonna happen is that you're gonna have a current here that's gonna be maybe, I don't know, I'm gonna put 50 microamp. Here, once it's charged, there's gonna be nothing here. Here, I equals 0. I equals 0 here, once it's charged. So it means that you can just get rid of it in the thing. It's not there anymore. I equals 0, so it's like open circuit. So now you only have this. So you have your 50 microamp current, and what's going to happen is that now you have to worry about the VBE. You want it to be greater than 0.6. It should be 0.7 to turn on the transistor. So let's look at the VBE. And when I did the experiment, I actually wrote down the voltage. It's 5. Here you have a voltage is equal to 5.18. Here you have a voltage right here. This voltage here is V equal 5.86. So 586 minus 518, it's about 0.7. So you have 0.7 volts, meaning that the transistor is turned on. So you have an IC here, and I don't know the exact value, but it's probably around 5 milliamp, let's say 5 to 10 milliamp, I'm not sure. Yeah, something like that. So here, of course, the LED is going to turn on because you have 5 milliamp. There's more than enough to turn on the LED, the LED. And if you want to know all the values, here I actually wrote them down. So here the V is equal to 2 point something, 2.05. So here at the LED you have a voltage drop of 2 volts. And here you have 518, so here you have also a drop here across that resistor, which is what you expect. So okay, so let's go back to it. Once the capacitor is charged, the current through it is 0. So it's basically an open circuit. You can just get rid of it. And for the transistor to turn on, so for the current to go through here, the VB junction must be 0.7. And of course, that's what we have, because we have, so this is 0, this is ground, 2.05, you have 518 here, and here you have 586 here. So you have 586 at the base minus 518 at the emitter gives you 0.7. So transistor is on. Okay. So now let's do the discharge. You're gonna, okay. So the 9 volt here still goes here. Okay. So initially you had 5 milliamp, and then when the switch goes to B, what's gonna happen is that the battery doesn't provide any voltage here. So now basically this thing is off. It's completely gone, this branch. Okay. So now you're gonna have a discharge. You're gonna have discharge, and so you're gonna have a discharge into the BE junction, and as long as VBE is greater than 0.6, the transistor is still gonna be on. So you're still gonna have the current going through, and the LED will still shine. So it will still shine. But what happens is that it starts at VBE equals 0.7, and as the capacitor discharges, the VBE goes down from 0.7 to 0.6, meaning that the LED is going to start to dim. So the LED is going to start to dim. And then at some point, it's going to reach 0.6, and then the LED is just going to turn off completely, because when VBE is less than 0.6, so this guy here, when VBE is less than 0.6, the transistor is off, so nothing goes through. So there's no current going through. So that's the whole idea. Okay, so that's all I wanted to show you today. A very simple circuit, but you kind of learn quite a bit from it, I think. And that's the beauty of those Radioshack electronic lab things, is that you have very simple circuits that you can build, and you see you can look at the voltages, you can look at the currents. You can also copy them into LTSpice, which is what I do sometimes, but sometimes I don't. You don't even have to, and you play with it. Until you understand what's going on. Okay. So that's the way I do it, and I'm gonna stick with it. Okay, I'll see you around. Bye.